Welcome back. In this video, we are going to talk about another one of the important programming challenge of Hackerrank, and name of that programming challenge is height of a binary tree. First of all, what we will do, we will try to understand the problem with the help of an example, and after that we are going to solve this problem by using a Java programming language. Okay, so let's start. So by name itself, you can understand that the input that we will get as a tree, for example, this is the tree we have got an input. Now we have to find out the height of a binary, height of this tree. So how we will know that what is the height? So whenever I say height, that means the maximum number of edges in a string in this tree can carry. For example, if I will say 4, 2, 1, so I can find it out there are 2 edges here. Okay, now if I'll find some other string from other string length, for example 4, 2, 3, there are also 2 edges there. 4, 6, 5, that is also 2 edges are there. 4, 6, 7, that is also 2 edges are there. So maximum height of this binary tree is 2. So this 2 will be our output. This is what we are going to return our answer to. So, okay, now what we will do, we will take one more example to understand this problem in a little bit more depth way. Okay, let's do that. This time I am going to take a tree. Now let's find out what is the maximum number of height of this tree. So if I will follow this node 3, 2, 1, so I can see that only 2 edges are there here. If I will follow 3, 5, 4, there also only 2 edges are there, but 3, 5, 6, 7, if I will follow here 1, 2, 3, here 3 edges exist. So this is the maximum height of this binary tree. So this one will be our answer. Okay, so we understood the problem. Now what we will do, now let's see the constraint of this problem. Constraints are that node data will be between 1 to 20, and the number of nodes, it will be between 1 to 20. This is the constraint. So what are the things we covered? We understood the problem with the help of an example. We also saw the constraint. Now the next thing that we are going to do, we are going to solve this programming challenge. Okay, to solve this problem, what we will do, we will take previous example as our input. Okay, so how can we do that? If we increment one by one with from the leaf node to root node, and through that if I will compare with each of them which one is the maximum, I will consider the maximum part whenever the adjoining node is there, and when I will reach the top of the root node, and through that I can figure it out which is the maximum. For example, let's say 1 here, this is the bottom, so I will add here 1. Here also this is the end of the leaf node, there also end of the leaf node 1. Now when I will go up, so 1 plus 1, again another node is there, I will make it 2. Another, I will, whenever a node will come, I will increment by 1, so 1 plus 1, 2, it will come. Now this is the adjoining node 5 is there, correct? So which one is the bigger, 1 or 2? So I can see that 2 is the bigger, so I'm going to discard this length and I will take this one. Now here another adjoining node is there, so 2 plus 1, here it will become 3. 3 is the length. Now I will come back here, 2 section, here 1 is there, after that again it will increment by 1, so 1 plus 1, this one will become 2. Okay, now this is again 3 is the adjoining node of both 2 and 5 node. So which is the bigger one, 3 or the 2? So 3 is the bigger one, so I'm going to discard this one and I will take this one. So again it will reach to the 3 section, the top root node section, and here it will become 3 plus 1, 4. So we got that this 3, 5, 6, 7 is the maximum number of node, that is 4. But we have to find the height of a binary tree, and height will be considered by number of edges, not by the number of nodes. So how we will know what will be the number of nodes? Whenever 4 is there, so I can see that in 4 nodes there is 3 edges will exist to attach this one, correct? To connect all 4. So what I'm going to do here, I'm going to write 4 minus 1 equal to 3. So we will get our output like this. This will be our output, correct? So now what I'm going to do, I'm going to replicate the same thing in the code. So you need to understand one important point. Whenever we will cover a tree, then the most basic concept that we are going to use recursion. By using recursion we can traverse the complete tree and we can compare all of them. So what we will do, we will compare in all the travel, we will increment add by 1, and after adding by 1, whenever the adjoining node is there, we will see which one is the highest. Root dot left is the highest or root dot height is the highest, and whichever the maximum, we will take that one, and again we will proceed, we will reach the end, and whenever we will reach the end, when according to that we will find out which is the maximum height, correct? So let's do that in the code. So this is the method inside where we are going to write our code, and here we can see that we are getting a tree with the help of this root reference, and which is called by node class. Let's go to this node class. Here I can see that in the node class there are 3 variables are defined here: left, right and data. Left will help to travel in the left direction, right will help to travel in the right direction of a tree, and data will help us to access the data, correct? Okay, now what are the things that we have to do? We have to find the maximum of math dot max, either it is root dot left or it is root dot right. So I'm going to write height root dot left height root dot right. Now I'm going to write here +1. Okay, and here I'm going to return this one. Return. That's it. Exactly the whatever I have explained in the editor section, I have done it here. So how it is going to traverse? It is going to traverse like this: root dot left and root dot right. Here again we can see that okay, here 2 node is there, root dot left and root dot right. So according to the recursion, it is going to travel like this. Okay, and whenever it will find nothing is there, then it will go back by adding increment by 1, and when it will reach in the top section, and according to that it will choose the maximum one, whichever is the greater. Either this is the greater or this is the greater, by using the math.max that we have written it here. Okay, up to that much we have done. Now so whenever it reached up to here, it has to display 4 minus 1 3 node, correct? So we have to stop at certain point at recursion, because you can see that we haven't given any stopping point here. So what I will do, whenever this leaf node ends, so that means it will be null, correct? Because beyond that nothing is there. So I can write a code here. If root equal to null, return. Okay, but after returning also there is one more problem exists. The problem is that we will get the number of nodes, but we won't get the number of edges. So what will be the number of edges? Number of edges will be total number of nodes minus 1. So what we will do, whenever we will got it here at the null point, we will add here -1. We are incrementing, whenever the node is there, we are incrementing by +1. Whenever the null is there, will be added by -1. So what will happen here? 4. So it will be added 4 minus 1. That will be 3, our answer. So what am I going to write here? I am going to write here return -1. So I think we covered all the sides of this logic. Now what we will do next? We will execute the code here. Let's execute the code. Right. Let's provide our input. we got our answer 3. So this is the output that we are looking for. We know that according to this example our answer should become 3, and here also it came 3. So I think the logic that we have written here is completely correct. Now what we'll do next, we'll go to the Hackerrank console and paste our code there. Let's copy this one. We'll paste our code here. Now let's run the code. Test case 0, test case 1 and test case 2 got successful. Now let's submit the code to see all the test cases. So the logic that we have written is completely correct. Okay, all the test cases got successful. So with that, this is the end of the video, and again in the next video we are going to cover another one of the important programming challenge of Hackerrank. Okay, and the code that we have practiced here I will provide in the GitHub, and GitHub link I will give in the description section. Okay, so stay tuned and keep watching Adhyan channel for the next upcoming video of a Hackerrank problem. Thank you.